Hello everyone, my name is Sohil Nagpal and in this video I will be demonstrating my task 5.2D above and beyond credit of the unit SIT202 Networks and Communication. So this is my summation, and on the first two pages we have the summary and reflection for the topics and the activities we have performed in this task. So to begin with, we have the module 2, that is the application layer. In this activity, we will be seeing the operation and handshake process of TLS using screen captures from Wireshark, including Internet Security Protocols like TLS. To analyze HTTPS traffic in Wireshark, we need the SSL TLS description key. By decrypting the SSL TLS traffic with the decryption key in Wireshark, we can view the HTTP communication in plain text. It is important to identify the message sequence and protocol used, including transport layer protocols, before sending the first HTTP GET message to the relevant web server. The TLS handshake process involves a series of messages exchanged between the client and server to establish a secure connection. Using Wireshark, I have captured and analyzed these messages, including the client hello, server hello, certificate servers key exchange, client key exchange, server cipher spec, and finished messages. I have explained the purpose of each message and how they are used to establish a secure communication channel. In conclusion, I have showed that Wireshark can be used to analyze HTTPS traffic by decrypting SSL TLS traffic and the decryption key. By understanding the TLS handshake process, we can better understand how communication channels are established between clients and servers. Now we will be talking about emails and their basic components. Emails use simple mail transfer protocol, that is SMTP, as the application layer protocol and TCP/IP protocol suite as the underlying architecture and transport layer protocol. To send an email, the sender creates a new message and connects to their outgoing mail server using SMTP on port 25 or 587. The outgoing server verifies the sender's credentials, looks up the reception's IP address, and sends the message over the internet using SMTP. The recipient's incoming mail server receives and stores the message before delivering it to the recipient's mailbox. Understanding these components can help troubleshoot email issues. Next we have the module 3, that is the transport layer. In this module we have the three most important flow control protocols used in computer networks, that are stop and wait, go back N, and selective repeat. Stop and wait is the simplest flow control protocol in which the sender sends one data packet at a time and waits for an acknowledgement from the receiver before sending the next packet. Go back N is a sliding window flow control protocol that allows the sender to transmit multiple packets before receiving an acknowledgement from the receiver. It is suitable for low bandwidth and short distance network with low error rates and is easy to implement and useful for applications that require a small amount of data to be transmitted. Congestion control is a critical component of the transport control protocol that is used to prevent network congestion and ensure reliable data transmission. It relies on network congestion signals to adjust the transmission rate to avoid overloading the network, and without proper congestion control, network congestion can occur, leading to packet loss, slow network performance, and an increase in number of retransmissions. Go back N is a sliding window flow control protocol that allows the sender to transmit multiple packets before receiving an acknowledgement from the receiver. Selective repeat is a sliding window flow control protocol that allows the sender to transmit multiple packets before receiving an acknowledgement from the receiver, but requires a more complex implementation than go back N and is not suitable for low bandwidth networks. Then we have congestion control in TCP, which helps to prevent network congestion, ensure fair sharing of network resources, avoid packet loss, and improve network performance. It reduces the rate of data transmission when the network becomes congested, reducing the probability of packet loss. It also helps minimize delays, packet loss, and retransmissions, which can all have a negative impact on network performance. So next we have the activity, and in this activity I have modified the Python program to include the mentioned functions. First, the client needs to send the message hello to the server. Once the server receives the message, it should respond with hello, what's your name? The client should then be prompted to enter their name via the terminal and send it to the server. Once the sender receives the name, it should respond with hello and the name of what we input there. Welcome to SIT202. All the messages, including the initial hello message from the client, should be displayed in the relevant terminal. These modifications can be achieved by adding appropriate send and receive function and modifying the existing code to handle the new messages. The final program should allow for a conversation between the client and server, where the server asks for the client name and welcomes them to SIT202 using their name. Next we have the module 4, that is the network layer data plane. In this module we have the most commonly used routing protocols, that are OSPF, that is open shortest path first, RIP, that is routing information protocol, and BGP, that is border gateway protocol. OSPF is a link state routing protocol that calculates the shortest path first based on a cost metric. RIP is distance vector routing protocol that uses the HOP count as a metric to calculate the best path to a destination network. BGP is a path vector routing protocol that selects the best path based on several factors including AS, path length, and metrics. OSPF is designed for use in large complex networks and is known for its fast convergence time, scalability, and support for variable length subnet mask. RIP is designed for for use in small, simple networks and is known for its ease of configuration and low processing power requirements. BGP is a path vector routing protocol that selects the best path based on several factors including AS, path length, and metrics. And then here we have the comparison between the three discussed protocol based on the key features, advantages, and disadvantages. Moving further, we have the module 5, that is the network layer control plane. In this module we will be analyzing DHCP in Wireshark. DHCP is dynamic host configuration protocol, which is used to dynamically assign IP addresses and other network configuration setting to devices on a network. Analyzing DHCP in Wireshark involves capturing and analyzing the packets exchanged between a DHCP client and server. To do this, we need to disconnect the wireless connection and connect it again while capturing the packets in the Wireshark. The captured packets will show the sequence of DHCP messages exchanged between the client and server, including DHCP discover, DHCP offer, DHCP request, DHCP acknowledgement, and DHCP release messages. Each message contains detailed information such as the client's MAC address, the IP address offered by the server, and release time. By analyzing these messages, one can gain insights into how DHCP works and how devices obtain IP addresses and other network configuration settings on a network. Then we have the intra-AS and inter-AS protocols. These are the two types of routing protocols used on the internet. Intra-AS protocols are used within a single autonomous system, that is AS, to exchange routing information between routers, while inter-AS protocols are used to exchange routing information between different autonomous systems. The main difference between intra-AS and inter-AS protocols are scope, goals, metrics, complexity, and complexity. Intra-AS protocols aim to determine the best path for packets to reach their destination within the same AS, while inter-AS protocols aim to enable routers in different autonomous systems to exchange information about the best path for packets to reach their destination across multiple autonomous systems. Example of intra-AS protocols include RIP, OSPF, and IS, while examples of inter-AS protocols include BGP and eBGP. The next module is the module 6, that is the data link layer. In this module, we will be discussing security issues associated with ARP identifying The types of attacks. ARP is the Address Resolution Protocol, which is a protocol that is used to map a network address, such as an IP address, to a physical address, such as a MAC address, on a local network. It is vulnerable to a number of security attacks, such as ARP spoofing or ARP poisoning, ARP flooding, ARP cache poisoning, and ARP suppression. To prevent these types of attacks, network administrators can implement a variety of security measures such as network segmentation, encryption, and tools like ARP Watch or ARP spoofing detection software. Additionally, deploying secure ARP protocol like ARP inspection and dynamic ARP inspection can help to mitigate the risk of ARP based attacks. At last, we have the module 7, that is the physical layer module. Here we have the two main types of Ethernet cables used in computer networks, which are straight through and crossover cables. Straight through cables are used to connect devices with different roles in the network, such as connecting a computer to a switch. At one end of the cable, the wire connections follow the T568A standard, while at the other end, they follow the T568B standard. Crossover cables are used to connect devices with the same role in the network, such as two computers directly connected to each other. So, a straight through Ethernet cable is a type of network cable that has the same wiring sequence at both ends of the cable. It is used when two computers are connected to each other, or when the transmit and receive signals are correctly connected. A straight through Ethernet cable is used to connect devices with different roles in a network, such as computers, switches, routers, and hubs. This type of connection requires the transmit pins on one end of the cable are connected to the receive pins on the other end of the cable, and vice versa. A straight through Ethernet cable is necessary because the transmit and receive pins on the devices are not the same. If a crossover cable was used to connect a computer to a switch, the transmit pins on both ends of the cable would be connected and the receive pins would be left unconnected. This would result in no data being transmitted or received, and the connection would not work. So a crossover Ethernet cable is a type of network cable that has a different wiring order at each end. It connects the transmit pins on one end of the cable to the receive pins on the other end, and vice versa. Crossover Ethernet cables are necessary for connecting devices with the same role in a network, such as the two computers directly to each other. To identify a crossover Ethernet cable, you can check the wiring sequence of the connector at each end, or use a cable tester or network analyzer tool. Examples of devices that require a crossover cable include two computers directly connected or two switches linked. So this was all about demonstrating the task 5.2D above and beyond credit for the unit SIT202 Networks and Communication. Thank you so much for watching the video.